Hello everyone, my name is Jin and today I'm going to be your teacher on the law of sines. Triangles are a big sign that there's a chance for you to solve a side or angle using trigonometry. The law of sines is an equation, as you can see here, that demonstrates the relationship between a side and its corresponding angle in any triangle. The relationship is the ratio between a side and the sine of the opposite angle. There are many different ways to use this equation to solve problems. It can be used to solve an unknown side or angle. Most of the time, the question gives you two sides and one unenclosed angle, or two angles and one side. For example, here in example 1, we can see that we have a triangle here with the angles 35 and 105 and one of the sides, which is 7. Here in the diagram, using the variables in the law of sines, we can see that side B is equal to 7, angle B is equal to 35, side C is what we're trying to find out, and angle C is equal to 105. Since the law of sines states that side B over sine angle B is equal to side C over sine angle C, we can plug these numbers into the law of sine. Now we know that 7 over sine 35 is equal to side C over sine 105. And to isolate C, we times both sides by sine 105. And the answer we would get would equal 11.788, which is side C. Here we have example 2. In the diagram, we are given two sides and an angle, and we are asked to find an angle. Thanks to the law of sines, we know that x over sine x is equal to z over sine z. We are told that angle x is equal to 36, side z is equal to 36, and side x is equal to 24. And we can plug these numbers into the law of sines, and the answer we would get would be 61.845 degrees for angle z. We have to make sure that we inverse sign the decimal because the decimal does not equal the actual value of the angle. The decimal is actually sine of the angle. But there is a twist to this question. There are actually two answers. This is because inverse sine 0.882 is also equal to 118.155 degrees. And how do we get that? Well, we just subtract 180 with 61.845. Both of these angles are suitable answers for the question since both triangles are possible. To prove the law of sines, we first label our triangle. Then we draw an altitude from any angle. Using the signs of the angles, we know that h is equal to side A times sine angle C, and that h also equals to side C times sine angle A. Since both these equations equals h, we set them equal to each other. Then we divide them by sine angle C first, and then sine angle A. But the order does not really matter here, because in the end, the result will still be the same. And we would get A over sine A is equal to C over sine C, thus proving the law of sines. We can also repeat the process to figure out how to prove for angle B as well, using the same kind of method, but just changing the variables.